Hi, this is textbook chapter 6, question 41. The question gives you the joint density of x and y is x e to the negative x times y plus 1. Okay, and these are the ranges. Okay, so A and B, A is asking you for conditional of x given y and condition of y given x. Okay, so you have the joint. By definition, in order to get x given y, we should get the joint x and y divided by the marginal of y. Okay? And then you know the joint, which is given in the question. And then the marginal of y is by doing integral of the joint with respect to x. Okay? So this is what you should do. The actual integral, once you do it, will be, the whole thing is y plus 1 squared x e to the x y plus 1. Okay, and don't forget the range of x. So similarly, to get y given x, you need to get the marginal of x. And then if you do that, that means you're getting integrating the joint with respect to y. Okay, and please do that, and that will give you x e to the xy, and then that's when y is greater than 0. All right, I want to focus on the second part mostly. So the second part, you still have this joint. And then xy greater than 0. So you asked to find the joint, like the density of z equals to xy. Okay, so this density, this is a new random variable. So if you try to get probability of the new random variable smaller than some number over here, that will give you p xy smaller than some z, which is this, the small z. So this again is a double integral exercise. So double integral of the joint density, which is x e to the x y plus 1 dy dx. That's what I'm doing over here. And then you want this region to be smaller than z. Okay, so the region, so it's a little bit harder to draw over here, but this region, if I'm going to do d, because both of them are positive, if I'm going to do dy first, I'm going to have, so let me keep writing. So if I do dx, dy first, I know that I should have to start from 0, but because the product of x and y is smaller than z, so here you have z divided by x, that will be the upper bound for y. Okay? And then for x, it would just be from 0 to infinity. So if you do that, that gives you 1 minus e to the negative z. Okay? So this gets you the CDF, right? So we talked about in class that from CDF to PDF, you're taking the derivative. So this function, which is the PDF, you can get it from taking the derivative of the CDF function with respect to z. So that means I'm taking derivative of z. If you do that, it's going to give you e to the negative z, and z is the range of that is larger than 0. Okay, so get it straight. You need to first of all start with the CDF. That's what it is, and this is a double integral. Once you get that, that is the CDF. And then from CDF to PDF, you need to take the derivative. Okay.